The diagram shows the apparatus used to investigate the diffusion of gases. Okay, so the question is asking which gas would diffuse into the vacuum at the slowest rate. So for it to diffuse into the vacuum, okay, the gas is here at room temperature and pressure. Of course, vacuum is a place where there is nothing there, so there is no gases, nothing at all. Absence of matter is what we call as a vacuum. Of course, here you have some gases here, and this is a porous barrier. A porous barrier would allow the gases to freely diffuse through it. So, of course, the gases here is going to move into the vacuum, right? And it's going to start filling up the spaces in the vacuum. So, the question is asking which gas would diffuse in the into the vacuum at the slowest rate. No doubt all of them are going to diffuse into the vacuum, but which one is going to diffuse in at the slowest rate? And of course, before we can do that question, so we need to know what is the chemical formula of each of the gases here. So the chemical formula for ammonia is NH3, and the carbon monoxide, mono means one, carbon monoxide means carbon is attached to one oxygen atom, so that's why it's called carbon monoxide. Hydrogen is a diatomic gas molecule, and you should know that hydrogen is H2. And sulfur dioxide, di means 2. So one sulfur atom is bonded to 2 oxygen atoms. So hence the formula for sulfur dioxide is SO2. Now that we know what is the chemical formula for each and every one of the gases listed here, so now we need to work out which one of the gases is the densest of all. So in order to find the density of the gases, we need to work out what is the MR value for each of the gases. So when we look at the MR value for ammonia gas is made up of 1 nitrogen bonded to 3 hydrogen atoms. So nitrogen has got a relative atomic mass of 14, and there are 3 hydrogens. Each hydrogen has got a relative atomic mass of 1. So 3 times 1 is of course going to be 3, and 3 if you add it to 14, it's going to become 17. So ammonia is going to have a relative molecular mass of 17. How about carbon monoxide? There is 1 carbon, 1 oxygen, and the carbon's relative atomic mass is 12. So 12 plus oxygen is 16. So if we add a 12 and a 16 together, we're going to have 28. Just by looking at this two, right, we know that ammonia is less dense compared to carbon monoxide. So if we want to find out which gas would diffuse at the slowest rate, if we compare between these two, carbon monoxide is going to diffuse slower compared to ammonia. But since we have not considered the other two options, okay, let's continue to work out the MR value for hydrogen. And of course, hydrogen, as we know, is the least dense of all gases. So there is 2 hydrogen atoms, each with an atomic mass of 1. So twice of 1 is going to be 2. So MR value for hydrogen is 2. And of course, this is going to be the one that's going to diffuse the fastest, right, into the vacuum. So how about sulfur dioxide? So the relative atomic mass of sulfur is 32, and there are 2 oxygen each with the relative atomic mass of 16. So twice of 16. So if we add a 32 to twice of 16, which is also another 32, 32 and a 32 is going to become 64. So when we look at all these 4 gases, we can see that sulfur dioxide has the highest MR value, or the relative molecular mass value, and hence this is going to be the clumsiest molecule, and it is going to diffuse at the slowest rate into the vacuum. So the densest gas with the highest MR value, sulfur dioxide, would diffuse at the slowest rate. Hence for this question, the answer is sulfur dioxide. Sulfur dioxide is going to be the last one to be able to get into the vacuum because it is the heaviest of all.